Right. Anyhow, let me just to recapitulate what we have done in the last class so that there is a connection between what we have done and today we are going to do it, right? So we were just looking at what is that resultant of general space force system. So we have taken this classical problem of a tetrahedron acted upon by three forces, and the process of finding resultant necessitate that you should understand the concept called equivalent force couple system, and that's what is helping you to bring in all these three forces F1, F2, and F3 to the point B. And when you have that, you have system of forces 3 and 2 couples at point B. So you are able to find the resultant of forces and resultant of couple simply addition of the vectors representing the magnitudes. So you got that. And at that point B, you have two vectors now. One is the resultant force vector, another one is resultant moment vector. And you are able to reduce further that shifting your resultant force R and the collinear component, that is this, to the force from point B to another point P. So how do you do that? So for that you require to find out what is the perpendicular component of the couple moment, resultant couple moment, parallel to the resultant force. So that's easy to find out. For that purpose, you find out angle between the two vectors R and M, and once you know the angle, then you are able to represent your total couple moment as a couple moment component parallel to the resultant force, perpendicular to resultant force. The parallel component to the resultant force can be estimated if you know couple vector and the resultant vector, because you have understood the definition called the pitch of the couple moment. So pitch represents it's an axial displacement of an identical part in a thread for one revolution. That's exactly what we have done in the last class. So you will be able to get P R. So I know this vector now. I know what is my couple vector. So I can find out what is this perpendicular component by this difference M minus PR, and I get my perpendicular component. And this can be further transferred to another new point wherein you see that is your point B. So for the point P, for that you define this point P x p comma y p comma 0, and this RBP cross R would be this. So RBP cross R would be what? Here I would have I, J, K. This is going to be XP, YP 0, and R vector is what I have got already here in this problem, which is 100. So here I'll have 100, 141.42, 158.58. So this determinant would have two unknowns, XP and YP, and I have a vector. And in this side, I will have a vector, M vector minus PR vector. I will have here some value of I plus some value of J plus some value of K. And here I will have again, I will have IJK vector, but in combination of this. So comparing IJK coefficient, I would have a necessary equation to solve for XP comma YP. And I know the point P wherein this couple is eliminated. I would have my collinear force and couple called wrench, right? That's what is called wrench. That's what in the last class we have just learned and stopped the class. Asked you to work out this, and still if you have not worked out, please do work on that.